An unknown compound was found to have a percent composition as follows. So we have our percentages. What is its empirical formula? And then if the true molar mass of the compound is this, what is its molecular formula? So first I'm going to find my empirical formula and assume that I have 100 grams. So that means I have 47 grams of potassium and 14.5 grams of carbon and 38.5 grams of oxygen. So then I'm going to convert each one of these to moles. So 1 mole is 39.1 grams, and that gives me 1.2 moles potassium, yeek, and 1 mole of carbon is 12.01 grams, and that is 1.2 moles. And 1 mole of oxygen is 16 grams, and that gives me 2.41 moles of oxygen. Then I'm going to divide each of these by the smallest, which is 1.2, so this is 1, this is 1, and this is about 2. So my empirical formula is K, I have 1 of them, C, I have 1 of them, and O, I've got 2 of them. So this is my empirical formula. Then they ask if the true molar mass of the compound is this, what is its molecular formula? So I need to calculate the molar mass of this first. So I've got 1 potassium plus 1 carbon plus 2 oxygen, and I get 83.11 grams per mole. So then I'm going to take the molar mass that they gave me and divide it by the molar mass that I just calculated. So it's molecular mass divided by empirical mass, and I get about 2. So now I'm going to go back and multiply all these subscripts by 2. So I've got 2K, 2 C's, 4 O's. This is my molecular formula. What is the empirical formula of the compound with the molecular formula of this? Well, I know my molecular formula. The empirical formula is just the reduced version, so I can reduce these each by 9. So I get CH2. That's it. What is the molecular formula of a compound with an empirical formula of this and a gram formula mass of this? So they gave me my empirical formula, and my molar mass of is this. So if I calculate the molar mass of my empirical formula, I'll just divide it by divide 172 by whatever I find. So I've got 2 carbons, 3 hydrogens, 1 oxygen. I get 43.05 grams per mole. That's a 5. Okay, so I'm going to take the molar mass of my molecular formula and divide it by my empirical formula molar mass, and I get about 4. And so I'm going to multiply all my subscripts by 4. So I get C8, H12, O4. This is my molecular formula. Nitrogen and oxygen form an extensive series of oxides with a general formula of this. One of them is a blue solid that comes apart reversibly in the gas phase. It contains 36.84% nitrogen. What is the formula of this oxide? So I know I have this much nitrogen. If I subtract it from 100, that's how much oxygen I have. So 100 minus 36.84 gives me 63.16% oxygen. Okay, then I just assume I have 100 grams. So I've got that many grams of nitrogen, this many grams of oxygen. So then I'm going to convert both of these to moles. So 1 mole of nitrogen, I've got 14.01 grams. That gives me 2.63 moles of nitrogen. Oxygen, I've got 1 mole is 16 grams. So that gives me 3.95 moles. Then I'm going to divide it by the smallest, which is this. So that's 1. And then this one, when I round to the nearest whole number, I get 2. So my empirical formula is NO2. Rubbing alcohol was found to contain 60% carbon, 13.4% hydrogen, and the remaining mass was due to oxygen. What is the empirical formula? Well, first let's find what my mass was of oxygen. So if I take 100, subtract my carbon, subtract the hydrogen, I will get oxygen, which is 26.6. So then I'm going to assume I have 100 grams. So I have that many grams of carbon, this many grams of hydrogen, and this many grams of oxygen. So let's convert these to moles. So 1 mole carbon is this, and I get, I should put grams, 4.99 mole carbon. Convert my hydrogen. I get 13.27 mole. And my oxygen, 16 grams. Oops, I get 1.66 moles. Okay, so then I'm going to divide each of these by the smallest to get my molar ratio. So this is going to be about 1.66. This is 8. And this is 3. So my empirical formula is C3H8O. A compound with an empirical formula of C2OH4 and a molar mass of 88 grams per mole, what is the molecular formula of this compound? Well, they already gave me my empirical formula, so all I have to do is calculate the molar mass of this. 2 times 12.1 plus my oxygen plus my 4 hydrogen, and I get 44.06 grams per mole. They tell me the molar mass is really 88, so I divide that by the molar mass that I just calculated and round to the nearest whole number. I get 2. So I'm going to take this and multiply all these subscripts by 2. So C4O2H8. That is the molecular formula. A compound with an empirical formula of C4H4O and a molar mass of 136 grams per mole. What is the molecular formula of this compound? So they already gave me my empirical formula. So I just have to calculate the molar mass. So I've got 4 carbon, 4 hydrogen, 1 oxygen, and I get 68.08 grams per mole. Alright, what is the molecular formula? Well, I'm going to take the molar mass they gave me, divide it by the one I just calculated, and that gives me about 2. So I'm going to multiply all my subscripts by 2. So I get C8H8O2. And that is my molecular formula.